Hello guys, how are you? In this particular video, we will learn the problem number 5, which is based on the low frequency response of CSCS JFET multi-stage amplifier. So here in this particular numerical, we will learn how to calculate the value of lower cutoff frequency, after which you will get the value of the constant gain which is required for the multi-stage amplifier. So let's learn the mathematical aspects of this particular low frequency analysis, low cutoff frequency calculation with multiple RC circuits in your multi-stage amplifier. Now in this particular video, we'll be having this particular circuit as an example to calculate the value of low cutoff frequency. Now let's see one by one what is given. GMO1 and GMO2, that are nothing but the offset transconductance, that is nothing but 5600 micromho. So value is given. VP1, that is pinch off voltage for stage 1, stage 2, identical, minus 4 volts. VGS1, VGS2, operating voltages, identical, minus 1.2 volts. Then RO1 and RO2, ideal case, infinite. CC1, CC2 are 1 microfarad and CC3 is given as 2 microfarad. So CC1, CC2, CC3 values are given. Hold on, this here CS1 and CS2 values are not given, and moreover in this circuit as well it is not yet shown. So I can say that this is the example where I will get the gain in the form of unbypassed capacitor circuit, right? So here first of all the question is, find AV, that is voltage gain, for overall multi-stage amplifier and the lower cutoff frequency. So two findings we have, and this may ask in your examination for 6 to 8 marks. So actually it's a very simple. If you go step by step, it will become very simple. So let's move on. First step will be for the calculation of GM1 and GM2. What are the parameters which are given for us? GMO, which is given, that is 5600 micromho. VGS1 and 2 for both the stages given, minus 1.2 volts. VP, which is given, that is minus 4 volts. What we'll have to do? We'll just have to put the values and get the answer of GM. So as far as GMO, VGS and VP is concerned, these three values are same for stage 1 as well as stage 2. So your transconductance for stage 1 and stage 2 will be similar. So that value comes out to be 3.92 millimho, right? So for both the stages, we will be getting the first value of the step 1, that is nothing but 3.92 millimho for GM1 and GM2 for stage 1 and stage 2 transconductance. Let's move again to the calculation of voltage gain. So for that we require this AC analysis, and obviously I have mentioned but not yet written over here, you have to mention that DC sources should be short circuited and all the coupling and bypass capacitances should be short circuited. Then and only then we can draw this particular AC equivalent model. Note that in this AC equivalent model I have drawn RS1 and RS2. So it's an example of unbypassed capacitor where you will be getting the reduced value of the gain. So let's move ahead to the calculation of the gain factor. So as far as voltage gain is concerned, here we'll be getting AV is equal to AV1 into AV2. So as far as AV1 is concerned, this AV1 is for stage number 1, right? This AV2 is for stage number 2, right? So let's calculate the value of AV1. First of all, we'll calculate the value of AV1, that is nothing but minus of GM into RD2 divided by 1 plus GM into RS1. Okay, so as far as this particular formula is concerned, everything is known to us, right? GM is equal to 3.92, RD2 is equal to 1.8, I guess, yes, 1.8, 1 plus GM is given, RS1 is given, that is nothing but 680 ohm, right? So just have to put the value, get the answer, check your calculation is working or not, and come to me. Here we'll be getting the value as 1.925 with negative sign as well. Similarly, we'll move towards for the value of, this is the value of for AV2, and AV2 is nothing but related to your RD2. So AV1 will have to calculate now. So that will become GM into, hold on, this value will become RD1 parallel to RG2. So here we'll be getting RD1 in parallel with RG2, right? So, but don't have to worry about that. This is because, see, the value of RG, simple mistakes, you just note it down. GM into RS2 over here we have to take the GM into RS1. GM into RD1 parallel RG2. Now RD1 parallel RG2 will become same as that of RG1 only. Why this is so? Because RD1 is having value 1.8 kilo ohm, RG2 is having value near about 7 mega ohm. So if you take the parallel combination, that will be nearly about RD1 only. So even if you neglect these values of RG2, that will also be fine, but you have to put it in a formula so that examiner will get to know that yes, you know that the concept is stage 1 is connected to the input impedance of stage number 2. So what we'll have to do, we just have to calculate the values in accordance with the values of GM, RD, RG2, RGM and RS. So here we'll be getting the value is 1.9244. Very slight change you'll be getting. So AV1 is equal to minus 1.9244 and here we'll be getting minus 1.925. So let's see how we'll be getting the value of AV. So AV is equal to AV1 into AV2 and that value will become minus 1.925 multiplied by minus 1.9244 and that comes out to be 3.70. So this is the gain. So we have got the first factor which is expected as far as this numerical is concerned. Not always this will be expected. So they may ask you only separate lower cutoff frequency as well. So here we have got the intermediate value of this finding, that is nothing but your AV is equal to 3.70. So the next important value we'll have to find out the lower cutoff frequency, for which we have to incorporate all the coupling capacitors. Here we have only 3 coupling capacitors into picture, so only 3 RC circuits. So mathematical calculation will become simpler if bypass capacitor are not placed. So let's see how to calculate the low cutoff frequency. How many RC circuits we have? 3 RC circuits we have. The first RC circuit at the input of stage number 1 where RG1 is connected and CC1 is connected, no other resistance capacitances. So this is because VGS1 is open circuit. So RG1 has nothing to do with the RS1 for the calculation of the lower cutoff frequency. As far as lower cutoff frequency fundamental formula is concerned, FL1 I can say 1 upon 2 pi R into C. Here I can say that R is equal to RG1 and C is equal to CC1. Now let's find out the value of FL1. Very simple. So put the value RG1 is equal to 82 mega in parallel with your 8.2 mega and C is equal to 1 microfarad which is given. So just put the value, get the answer, check your calc is working or not and come to me. This value is very less. It's nearly about 0 only. So it's all about 0.0213 Hertz. It's a very low value. So let's move to the next part of AC circuit, that is RD2, RL and CC3, that is nothing but the output of stage number 2. So similarly as that of your input of stage 1, will calculate the value of FL2, that is 1 upon 2 pi RC under consideration of R is equal to RD2 plus RL. So here the value of RL which is given as 2 kilo ohm. So here R is equal to RD2 plus RL we have to consider, and that is you have to calculate 1.8 plus 2, that is your 3.8. okay, so 3.8 kilo ohm, that is the value of R, and C is nothing but 2 microfarad that is given. Okay, so what will be the value of FL1? FL2 you will be getting. So calculate the value of FL2 and again come to me, put the value, get the answer. 20.94 is the value Okay, so we will be getting the value of FL2 as 20.94 Hertz. That is the first finding, this is the second finding, or vice versa. I can say this is your equation number 1, this will be your equation number 2. Okay, now we will say that we have to move ahead for the third and last RC circuit, that is intermediate between your stage 1 and stage 2, intermediate RC circuit. So in between stage 1 and stage 2, we'll be getting two resistances. One is your output resistance of stage 1 and input resistance of stage 2, and in between we'll be having the coupling capacitor CC2. Here I have drawn dotted line, and that line is for RO, but see that RO, if it is given as infinite, then you have to consider it as infinite. If it is infinite, then I can say that RD1 in parallel with RO, that forms your RD1 only. So don't have to consider this RO, I just have drawn in dotted line, so we don't have to specify in your FL3 calculation. So FL3 is equal to 1 upon 2 pi R into C. Your R value is nothing but the addition of RD1 and RG2. So RD1 plus RG2. So this particular value you have to calculate. RD1 is 1.8 and RG2 is in mega. So this value will become very, very high value. So 7.4546 mega. Oh, so 7.456 mega ohm. It's a very huge value. And C value is given. C is given, and C is nothing but CC2. That is nothing but the value which is given as 2 microfarad. Okay. So here we'll be getting the value as 2 into 2 pi into 7.456 mega. This is also very, very less. I can say that 0.01. So you'll get the value 0.01 Hertz. It's a very less value that we'll be getting for FL3. Okay. So out of these three, obviously you will be getting the second value. If we say that lower cutoff frequency I want to find out, and as we have learned already, lower cutoff frequency is nothing but the maximum out of all these cutoff frequencies formed by the RC circuit, and here we'll be saying that the values max of 0.01 Hertz, 0.02 Hertz, and 20.94 Hertz, right? So as I said that maximum value is this, so I can say final value FL is equal to 20.94 Hertz is your lower cutoff frequency. So this is your another answer where the numerical is expecting in the question. Okay, so as far as the question is concerned, we fulfilled all the findings for the numerical which is given. So in the next numericals we will study more complexities and findings. So stay tuned for that. Learn more and more ADC with me with Ekeeda videos. Subscribe all the channels of Ekeeda videos. Thank you so much.